Hey, Harsh here. Today we are going to cover database keys. In this video, we are going to go beyond the basics from like basic keys like super keys and candidate keys to distributed Snowflake IDs and temporal keys. A key is your data's fingerprint. It's the unique mark that identifies one and only one record in the table. Without keys, your database is chaos, duplicate rows, conflicting values, and inconsistent joins. Keys enforce uniqueness and connect related tables, turning raw data into structured relational intelligence. They aren't optional, they are the foundation of reliability, performance, and trust in every query you run. A super key is any combination of columns that uniquely identifies each record, even if it includes extras that you really don't need. If employee ID alone is unique, then employee ID and department ID is still a valid super key. It's the broad, redundant set that guarantees uniqueness, the starting point from which we will extract the minimal and perfect subset called the candidate key. Candidate keys are the distilled essence of uniqueness. They are super keys stripped of that redundancy, minimal, non null, and sufficient to identify each row. A table can have many student ID, email, or roll number that could all qualify. Among them, one will be crowned the primary key, the official identifier that defines entity integrity. The primary key is the database's single source of truth, one per table, always unique and never null. It's how every other table safely references your data. The moment you define it, your DBMS automatically builds an index for lightning fast hookups. Break its rule, insert a duplicate or a null, and the system rejects it immediately. This is why every solid schema must start with a well chosen primary key. A unique key also enforces uniqueness, but with more flexibility. Unlike the primary key, it can allow a null value. That is why fields like email or username often use unique keys. They must be distinct, but they may start empty. You can have multiple unique keys, but only one primary key. Think of the primary key as the core identity and unique keys as trusted alternates. Once the primary key is chosen, the remaining candidate keys become alternate keys. They still maintain uniqueness and can step in if the primary key ever changes. For example, employee ID might be your primary key, but email can serve as an alternate key. Still unique, still reliable. Sometimes secondary key is used for fast search indexes even if they don't guarantee uniqueness. Foreign keys connect tables. They enforce referential integrity. A foreign key in one table references the primary key of another. It guarantees that every record in the child table corresponds to a valid record in the parent table. Without it, often data spreads like broken links in a website. Foreign keys can have duplicates, can be null if optional, but must align with valid parent keys. They are what make databases relational. When no single column can uniquely identify a record, combine them. A composite key uses multiple fields together like student ID, course ID in a enrollment table. Individually, both repeat, but together they form a unique pair. Composite keys shine in junction tables for many to many relationships. If defined as your primary key, it's called a composite primary key. A surrogate key is a system generated ID, a simple, stable, and meaningless. A natural key uses a real world data like email or SSN, meaningful but prone to change. Surrogates are preferred when natural data can't involve or isn't guaranteed to be unique. Use both the surrogate as your stable primary key and the natural as your alternate key for business logic. This balance brings both performance and context. So here's your quick reference guide. Primary keys are unique, not null, and one per table. Unique keys are unique, allow one null, and multiple are allowed. Foreign keys can repeat, may be null, and the link tables. Candidate keys are minimal and non null and can be multiple per table. Super keys is any unique set redundant or not. Keys aren't just for integrity, they are your performance engine. Primary keys are automatically indexed, giving you log and lookups. But here's the pitfall: if you don't index your foreign keys, joins slow down exponentially. Every query becomes a table scan nightmare. Always index your foreign keys with an asterisk. It's a difference between sub-second queries and multi-minute queries. In distributed systems, traditional auto-increment keys fail. They depend on the single node. UUIDs solve uniqueness but wreck the index order and storage. Modern architectures use time-ordered IDs like ULID and Snowflake IDs, combining timestamps, machine IDs, and sequences for globally unique and chronologically sorted keys. Such big words. They eliminate bottlenecks, enabling billions of inserts without central coordination. Modern databases don't just store what's true, but they store when it was true. Temporal keys add a time dimension to your primary keys, ensuring your records don't overlap in validity. In SQL 2011, they introduced primary key without overlaps to enforce this rule. In Postgres 18, even supports bitemporal keys, tracking both when a fact was valid and when it was recorded. This is essential for auditing, financing, and compliance systems. In finance, healthcare, and government, keys are more than identifiers. They are kind of your legal anchors. They power audit trails, ensure data lineage, and prevent integrity loss. A missing or broken foreign key can violate GDPR compliance by creating unfound or untraceable data. Modern systems pair this with cryptographically strong key generation and automatic rotation tools using KMS or key vaults. Key selection is strategic. Identify all the candidate keys, filter out anything that can be null or volatile, choose the most stable one as your primary key, keep meaningful alternatives as unique keys, always index foreign keys, asterisks. Surrogate keys win when real world data changes often, and natural keys win when business semantics matter most. Let's recap. Primary key is a unique, not null, single per table. Unique key allows one null and there are multiple allowed. Foreign key links table and enforces referential integrity. Candidate key is minimal and unique. Primary key is foundation. Modern systems rely on ULIDs, Snowflake IDs, and temporal keys for distributed and historical data. Designing keys correctly prevents duplication, enforces consistency, and guarantees long term system stability. Hey, if this video helped you understand this topic, don't forget to like and subscribe. You can also drop your suggestions down in the comments about the improvements and the topics you would like me to cover next. Till then, thanks for watching, and I will see you in the next one. Peace.